So the last thing that we want to do right up front is sort of give ourselves an overview of some of the types of motion that we'll be talking about as we go through the mechanics section of the course. One way that we can frame motion very basic is just whether it is uniform motion or non-uniform motion. And as we get into talking about the causes of motion, we'll see why this distinction really matters, right? The uniform motion is when an object continues to move as it is currently moving. Many of you, I'm sure, have heard the phrase before that objects remain at rest or objects continue to move in a straight line at a constant speed. Those objects are undergoing uniform motion. Non-uniform motion, of course, is when an object changes how it's moving. So how can it do that? Well, it can speed up, it can slow down, it can change directions. All of those are options in terms of changing how it's moving. We're going to start the semester, regardless of what type of object we're talking about, we're going to model it as if it were a point particle. So we're going to say shape doesn't matter, size doesn't matter, because it's just going to take up a single point in space. There's a lot of problems that, as we're going to see, that we'll be able to work, for which this is a perfectly reasonable model to use for whatever our object is. But so when we're thinking about point particles as they're moving around, again, there's some basic types of motion that we can think about. So one of those is linear motion. Again, this is just what it sounds like. Your object is moving in a straight line. So it might do that at a constant speed. It can speed up. It can slow down. It can slow down to the point where it turns around and starts moving in the opposite direction, right? But it stays on that single line. A second type of motion that we'll talk about for point particles is circular motion. So this is just what it sounds like. Your object is moving along a circle. Now maybe that's just the arc of a circle rather than an entire circle, but your object is moving along a circle, right? And again, there's two ways that we'll talk about circular motion. We'll talk about uniform circular motion, which is where your object moves along a circle at a constant speed. And as a general rule, we'll see that happen when our circle is horizontal, right? You can also have non-uniform circular motion. So this is where you're moving along the circle, or maybe just an arc of a circle, and you're changing speeds as you move along the arc. So swinging back and forth is non-uniform circular motion. You're moving along the arc of a circle as you swing, but you're doing it at different speeds as you go. Linear motion gives us the chance to change the magnitude of the velocity, slow down, speed up. Circular motion gives us the chance to turn. So if we combine these two things, we get what's known as curvilinear motion. And this describes basically the object that's moving along any curved path. So again, we have all three of the ways that you can change the velocity vector here. You can speed up, you can slow down, you can turn. We've seen that you can do both of those at the same time. So you can be speeding up and turning, you can be slowing down and turning, right? The example that we'll probably see the most, or at least certainly the ones that you've seen the most prior to this class, is projectile motion. So projectile motion is a curvilinear motion. You throw a ball across the room and it's moving along a curved path. Again, what type of motion projectile motion is dependent on the initial velocity. So if you throw the ball straight up, that's actually linear motion. It's going to go straight up, it's going to come straight back down, right? But if you throw the ball out, so there's some horizontal component as you project it outward, that's going to be curvilinear. So again, it will have some uniform horizontal motion. Its horizontal velocity won't change, but it'll have non-uniform vertical motion. So as it moves up, the vertical component of its velocity will decrease until it gets to zero at its highest point and then start increasing as it comes back down. So projectile motion is just one of multiple, but it's the one that we probably are most familiar with in examples of curvilinear motion. So what are other point particle motions that we're going to see? Well, what if I take a mass, attach it to the end of the spring, and then let that spring bounce back and forth? And again, it doesn't really matter whether this is it's bouncing back and forth horizontally across some table, it's bouncing back and forth vertically because I'm holding the spring and letting it drop and fall. In either of these cases, what I've got is a special type of motion known as simple harmonic motion. And because it's bouncing back and forth in a line, this is what's known as linear simple harmonic motion. Again, I have linear motion that happens to be simple harmonic. If, on the other hand, I took that mass and instead of attaching it to the end of a spring, I attached it to the end of a string and then let it drop, pulled the mass out, and let it go so that it swings back and forth. Again, I've still got simple harmonic motion. It's just this time it's not linear simple harmonic motion. It's not bouncing back and forth along a line. It's swinging back and forth along the arc of a circle. So I'm sort of pairing this special type of motion, simple harmonic motion, with my other types of motion. So linear on the one hand, circular on the other. Simple harmonic motion happens to be a special case of what's known as periodic motion. So periodic motion is a motion that repeats itself after a certain period of time. Simple harmonic motion is one of the types of periodic motion that happens to be an oscillatory motion. So it's a periodic motion where your object moves back and forth over the same path about an equilibrium point. And just to be clear, so when we talked about, hey, if there's an object undergoing uniform circular motion, let's say it's some object that's swinging around in a horizontal circle at a constant speed, that is also periodic motion. It's not oscillatory motion. So again, as it goes around in a circle, it completes its circle in some chunk of time. That's known as the period, just as the same way that same mass, if it swings back and forth to go all the way across and swing back to where it started, that's also known as the period. So both of those motions are periodic. One of them is swinging back and forth along the same path about some equilibrium point. Uniform circular motion, again, it's following the same path, but there's not an equilibrium point that's dictating why it's following that path. We'll see a lot of different types of motions for point particles. We'll get to a point in the course, though, where we'll start to think about extended objects. And so for extended objects, not only does their center of mass move, but now they might rotate about their center of mass. And this gives us more types of motion. So translational motion is the phrase we'll use to describe the motion of the center of mass of an extended object. And as we'll see, this is really just the label that describes the motion of any point particle, right? So the motion of point particles and the motion of the center of mass of extended objects, those are all sort of encapsulated by translational motion. But with my extended object, I also have rotational motion. I may have the center of mass of my object pinned in place so that that's what my object rotates about. So it doesn't have translational motion, it just has rotational motion. Or it may be a situation where I have both translational and rotational motion. So examples of this might be if you throw a stick and you flick it just the right way when you let it go so that the stick spins as it moves through the air. Well, its center of mass is undergoing projectile motion, plus there's the rotational motion of the stick about its center of mass. I can also think about both translational motion and rotational motion when I have rolling motion. So again, if I think about a ball rolling across a surface, the center of mass of the ball, that moves, and the rest of the ball rotates about that center of mass as it rolls. So again, as we start thinking about extended objects, we'll be able to include both translational motion and rotational motion. So all of these are sort of the basic types of motions that we're going to be looking at over the next couple of months of the semester. So we'll sort of keep coming back to these and adding on more and more of these as we go.